Hey, what's going on, everybody? How are you doing? Cobra Bubbles coming in with the 6 Kerbal years of support. What is going on, everybody? Hope you guys have been doing good in my absence. I am back, at least for today, for Starship Flight 9 here, set to take off in just 46 minutes from now. Where are we in the countdown? We've essentially gone through the go, no-go for prop load. Prop load has started. I believe Starship started around 10 minutes ago, booster maybe around 5 minutes ago. Both vehicles are now starting to fill up with propellant. Oh, and I hope they go all the way through T-0. We should see a launch today, and yeah, it's gonna be good, chat. We haven't seen Starship flight in I don't know how long it's been. It's been quite a while. Yo, and Bravo Alpha Echo Bay coming in with the 35 Kerbal years of support. Much love to you. Goodness, starting the stream off on a good note. So we are kicking off the live stream coverage here, starting off with NSF NASA spaceflight, as they always do. Fantastic footage and coverage for the early stage. We should expect, I believe, SpaceX to start their live stream in about I think like 5 to 10 minutes from now, and they actually might push it. They've started everywhere between like 30 minutes T minus and 20 minutes T minus. Their Twitch channel said, or not Twitch, their X channel says that they should be starting at 4:50. We'll see if that actually sticks through and whatnot. What's up, Supersonic? How are you doing? What is the plan and goal for today's launch? Well, first and foremost, to have a successful launch. I don't need to tell you guys that SpaceX has unfortunately had 2 of their last, or the last 2 launches fail, with their Starship basically blowing up around the 8-minute mark. So that's not good. So they've, of course, testing more design iterations. If you guys remember, Flight Test 7 essentially experienced a rapid unscheduled disassembly due to changes in the structure, hitting a resonance frequency that basically made propellant feed lines to the engine separate in the engine compartment. Basically the sea level, or no, it was the vacuum level, or I should say a vacuum optimized Raptor on Starship, basically start leaking propellants. Those propellants caught fire. There was insufficient systems on board to combat that fire. The fire grew until it basically exploded. And then Flight Test 8, the last one, funny enough, actually failed in almost the exact same way and place, but they said in their report that the failure was actually not in family with Flight Test 7's failure, meaning that it wasn't the same direct cause, root cause. So that's good. So dissimilar failures, but still the last 2 vehicles failed. The last failure happened because I think one of the center engines on Starship basically had like a turbo pump failure. The turbo pump, or some part of the engine, they say had a failure, basically ripping open or catastrophically failing in some way that also affected the engines around it, and they lost thrust vector control, and they lost all but like one vacuum optimized Raptor, so it started to tumble and then it ripped itself apart. So yeah, we're hoping first and foremost to see a good launch for Starship. The mission for today is very, very similar in terms of overall mission objectives and things being tested from the last flight. Let me actually pull out my handy dandy notes here. Yes. Oops, you guys cannot see that. There we go. So from my notes, they are, of course, testing Starship 35. This is the 3rd iteration, 3rd block, if you will, of their V2 Starship. Hoping that this one makes it all the way. 3rd time's a charm, right? 3rd time's a charm. Hey, what's up, gaming? How are you doing? So Starship 35 is on top of booster 14-2. A big test for today is their reflying booster 14, which flew, what was that, Flight Test 7? Was booster 14 Flight Test 7? I think it was Flight Test 7. But yeah, they're reflying booster 14, which is fantastic. So this will be the 2nd flight of this booster. And not only is it the 2nd flight of the booster, they're reusing 29 out of 33 engines on the first stage. So they've had to swap out for whatever reason, 4 of the first stage engines, but they're keeping 29, which is awesome. Hey, can I humble brag right quick? Of course you can humble brag right quick. What's up, JP? How are you doing? Good to see you, man. Glad to watch this launch in this stream. Well, much appreciated. Welcome in. Welcome in. Confident we'll get past Seco this time. If not, at least we'll probably get an uplifting speech from Elon after. That's true. That's true. I have a phone call with Blue Origin later this week. Hell yeah. Well, cheers to you, my friend. Cheers to you. Yeah, best of the very best of luck with the Blue Origin phone call. Yeah, Blue Origin is no joke with their job application process. But yeah, so overall, this mission is going to be testing a number of improvements. Like I said, not only are they going to be reflying Booster 14 for the second time, reusing 29 out of 33 Raptor engines on that first stage. They're also going to be testing on booster and off nominal booster landing. So it is important to note up front, we are not expecting, well, we will not see a catch tower attempt. Booster 14-2 is going to be landing in the Gulf, testing an off nominal booster landing. Essentially what's going to happen is that they are going to purposefully not ignite one of the 3 center Raptor engines that Booster typically uses to land, and they're going to instead test how Booster might be able to use one of the outboard engines within that ring of 10. So you basically have 3 in the center, 10 on the outboard, and then 20 on the outboard of that. So they're testing if you have an engine failure on one of the 3, can they offset that failure with one from the ring of 10? So that's going to be interesting to see. And then not only that, they're testing a different, not only a different boost back configuration, but also a different booster entry profile. So booster 14-2 is going to be testing a very high angle of attack return. Basically meaning if you guys have seen Falcon 9 launches that we've covered here, like the last transporter mission, I think, if I recall correctly, had a great view of this. Falcon 9 comes in like sideways. It almost looks like a plane flying in towards the landing zone when it does RTLS landings. Booster's going to be attempting to do that. Like the last several trajectories had it coming in mostly, straight down towards the tower. This one's going to be flying. So they're testing this because they want to see if flying at this higher angle of attack during descent can save propellant because they're increasing drag on the vehicle. If you increase drag on the vehicle, your vehicle ends up going slower, faster, and therefore you can use less propellant for deceleration and save that propellant just for controlling towards the tower. So overall, you use less propellant in the landing process. I mentioned that they are going to be testing a new hot staging configuration. They are purposefully blocking some of the vents in the hot staging ring. So if you guys know, right, the Starship system, when it is time for separation, basically Booster shuts down its engines, but right before it does, Starship actually starts its engines. It's called hot staging. Before it separates, the Starship engines will ignite, and that's what basically carries Starship away as Booster is then going to flip around and do their boost back burn. So in the past, flights 1 through basically 8 so far, have basically had Booster during separation just try to stabilize based off of whatever direction it's going. They actually were using the exhaust of Starship impinging upon the vehicle to help flip it around for the boost back. They're now purposefully blocking parts of the vents to help try to, I guess, determine the direction that the booster is going to flip. So they're trying to, again, use less propellant in the flip and burn, so that way they have more propellant later in later flights to actually push Starship into orbit. So it's very, very cool. They're testing a lot of trajectory modifications and things like that for Booster 14-2, which is going to be, it's going to be good. It's going to be good. With how big Super Heavy is it it has to have a good amount of body lift. Yeah, no kidding, Xerax, no kidding. It would actually be really cool to see some sort of analysis on just how much body lift it has, but you're absolutely right. It has such a huge fuselage, if you will, that yeah, I am excited to see how this high angle of attack return actually plays out, because if it's anything like Falcon 9, Falcon 9, right, is actually a really skinny rocket for how tall it is. Falcon 9 can fly almost sideways. So yes, very excited to see how that happens. And then, of course, all of that to happen, chat, we are still testing V2 Starship, right? This is the version 2, Block 2 Starship, if you will, that has unfortunately had 2 of its 2 flights end in failure, basically not even making it to SECO. So anything past SECO today will be excellent. But yeah, so Starship V2 is looking for its first successful flight. They're not only looking at using reduced tiling area on V2 Starship, because that's going to help it be able to go into the catch towers and be lighter overall as well. This one also, this particular Starship, Starship 35, also has a functional catch pin. So if you remember from the last 2 Starships, what was that, 33 and 34 from Flight 7 and Flight 8, they had the catch pins on there, but they were basically just peripheral. They were non-functional. They were just bolted onto the side in a sort of shape and configuration that an actual functional catch pin might be. Starship 35 is actually integrated into the structure. They have functional catch pins. Now, of course, we're not going to be seeing a catch tower attempt today, but it is cool to see them again iterate over the design and start to I guess provide a fully functional Starship V2. Not only that, we're also looking to, of course, still test for the first time metallic and actively cooled heat tiles. So if you guys remember, all the way back from the early days of Starship when they were testing the tiles, the catch arms are moving. Is it moving or is the camera moving? Okay, it's just the camera moving. For a second, I was like, why are they moving the arms up and down? That's typically not done. Anyways, so the tiles that are on Starship V2, they're testing certain areas with both metallic and actively cooled heat tiles. So instead of being the like Pika X or the tough rock style of like carbon ablative heat shields, heat tiles, heat shield tiles. Oh my gosh, English. They're going to be using reusable metallic and actively cooled heat tiles. Actively cooled meaning that they actually flow fluid in between the tiles to actually take away the heat from the tile, and that allows you to have arguably a reusable tile system, since you don't have to worry about it ablating and things like that. So still testing, still looking to test through reentry those heat tiles on Starship. All right, I mean, I think that's kind of the whole breakdown. We're waiting, I think, for, let me check real quick, waiting for SpaceX to start their live stream, which should be here. So yeah, it says 450, but I don't think they've actually started yet, question mark? Ah, they have. So I'm going to stop talking now, at least for a second, to see where our countdown and see who's doing the live stream. We're gonna cut the music, go to the live stream broadcast, and then I'll catch up with chat after that whole spiel.
That in just a couple of minutes. We're also hoping to get Ship into space, and it's got a couple of objectives like deploying.
So gaming, basically a body that creates lift. It's called, you're creating body lift. A lifting body creates body lift. It's just I guess a qualifier to note that there's no wings on the system. So the type of lift that system generates is from the body, so body lift. But yes, body lift is generated from some sort of lifting body force.
And of course, whatever happens, excitement is guaranteed.
That is true.
That's right. Progress is not.
But my gosh, chat, if you ask me, I mean, they're testing, right? They're testing. It's understandable, but SpaceX needs a win today. SpaceX really needs a win today. Third time is the charm. Knock on wood, fingers crossed, all of that jazz. I really want them to see all the way through entry.
Fully reusable and built for frequent flight and heavy payloads, just like today's commercial airliners.
It's the product of years of rapid development, testing, iteration. We're trying to fly as frequently as possible, fix problems as
it is kind of crazy
and then fly again.
To think that Starship that we're seeing here started back in 2019 when they first started developing prototypes of with Hopper.
water tower. We turned it into a water tower eventually. It made its first low altitude hop back in 2019 here at Starbase. You could tell the pad, that's the pad that we were just looking at. It looks dramatically different now.
Yeah,
the two towers.
they have come a long way
Starhopper delivered
in just
was able to
5.5 years.
Use that Raptor engine for controlled takeoff and landing.
Let's see the new flaps do work. Yeah, hopefully no burn through. That'd be great.
On your screen was just 6 years ago, and now we're here today with a full-size vehicle. So from there, we moved to full-size test articles.
What a great day that was,
complex test flights that reached progressively higher altitudes, and each test shaped the Starship that we see today on the pad a stronger, taller, and more refined vehicle.
That's right. All right, now let's go out there and meet it. Starship is made up of two parts. First, on the bottom, the Super Heavy booster, powered by 33 Raptor
Even with
engines.
burn through, they're resilient. That's true.
Ship are running on liquid methane
that is
and
true.
liquid oxygen. That
Starship 5 and 6, we saw. No, Starship 4 and 5, we saw burn through, and they survived.
Sea-level performance, 3 for vacuum, so operating while they're in space. And here's a quick look under the hood at all of those Raptors. On the left, that's a view from underneath the launch mount. 33 Raptor engines
on the first stage
on the booster.
Stop
and on
copying
the right,
me.
That's a view inside of the ship, so you're looking down at the top of the booster at 6 Raptor engines.
These are the vacuum optimized Raptors. They have this huge expansion nozzle attached to what would typically be just a normal Raptor engine. So like same pumping, or most of the same like turbo machinery and pumps and things like that, and plumbing, but bigger, optimized for a vacuum, higher efficiency in a vacuum.
These missions beyond low Earth orbit, that also unlocks our ability to.
Were those with the green flame? Yeah. If you're talking about the steel melting, yeah.
Far beyond Earth.
Yeah, the Super Heavy booster is designed to launch, separate, flip, and return to the launch site where it can be caught by the chopsticks on the launch tower. Though, as we mentioned earlier, we are not attempting a booster catch today on Flight 9. Starship re-enters the Earth's atmosphere at the conclusion of its mission, steering itself to a vertical landing or catch, and both stages are designed to return to Earth and fly again, making this the first rocket in history that will be fully reusable.
And then just in between the two vehicles is what's known as the hot stage ring. That's a steel structure that really
the igniter creates a green flame, but also, to my knowledge, the Raptor engines, because they're using 2 cryogens, they don't use TTEB, right? So typically a Falcon 9 first stage engine, or the Merlin 1D engine on first and second stage of Falcon 9, they have a pyrophoric mixture. Pyrophoric meaning that when it comes into contact with oxygen, they spontaneously combust. It's called TEA and TEB, TEB. TEA, TEB, TTEB stands for triethyl aluminum and triethyl borane. When those two fluids come together, they create a pyrophoric mixture that, when it floods into the combustion chamber, which is flowing liquid oxygen, that reacts, creates combustion, and then they could start flowing the RP1 and sustain that combustion. To my knowledge, Raptors, because they're using methane and liquid oxygen, they do not use TTEB, primarily because you can actually use the gases from those and use basically what's known as a oxygen augmented spark igniter, meaning that you flow a little bit of oxygen and a little bit of methane together, and you quite literally have like a spark plug in there. It combusts, basically creates a torch into the combustion chamber as you're flowing your main propellants, and that ignites the vehicle. But I don't know if that's what they use. I don't know the specific architecture of Raptor and how they start the engines, but I'm pretty sure they don't use TTEB.
That's a lot of Millennium Falcons,
so
Dan.
Many.
We're also currently in work on Starship's
all right,
brand
RJ,
new pad
nice.
Kennedy Space Center's Launch Complex 39A.
Is it me, or were there no
that online later this year as well?
Ceiling?
Tons of progress with Starship so far in 2025.
No false
and
ceiling?
Lots of incredible milestones still coming up. And we are still on track to lift off tonight at 6:30 p.m. Central Time.
27 minutes, chat.
Right now, it's time to say hi to Chris, who's over there repping the West Coast.
He used to work for NSF.
How's it going, Chris?
Hey, Jesse and Dan, and welcome everyone to West Coast and Hawthorne, California. As you can see behind me, the crowd is gathering outside of our mission control room here in Hawthorne, and the excitement is really palpable as we continue to count down towards Starship's 9th flight test. Now, our mission control room here in Hawthorne usually
I'm surprised Starship can bring you out of the shadows and stream.
And Dragon missions once they launch from
I'm glad you're surprised.
California. Now, with Starship, all countdown and mission control
if
operations
anything could, it's definitely Starship. I thought it was time.
From the same location of
hey,
Starbase,
Elon,
which you can see on your screen
in mission
now.
control.
But as we develop a vehicle like Starship, we want as many experts watching over its various systems as we can. And that's what we use the mission control room
the shielding
here
above
in Hawthorne
Raptors, gotcha.
During Starship flight test
so,
like
no,
today's.
not on Starship.
The folks in mission control, which you see now
Booster,
on your screen,
Booster
are the responsible engineers for Starship's various systems. This includes things like booster systems, stage propellant, our ground stations, flight software.
Naps coming in with the 8 Kerbal years of support. Much love to you, Naps. Yes, the rare rocket guy sighting indeed. I'll be streaming more
really important
frequently
when we're making informed decisions very quickly.
There's some personal things going on in the life that
this setup has been great for Starship flight tests so far, as we've handled things like propellant temperature differences, as well as day of launch winds that can affect the loads placed on Starship.
You bet he's playing Path of Exiles? Yeah, for sure.
During the descent of the Super Heavy booster back to Earth. So having all of these responsible engineers ready to support is crucial during Starship testing, where we place hardware
it's so
in
cool.
flight conditions.
If you guys have never been to the Hawthorne facility, having this right here I think is so cool, to where you can have all the workers and whatnot come up to the mission control window and see everything that the mission control sees. It's so good. And of course Blue Origin and others do that now too, but
I'm sure
it's
you
awesome.
all feel the same way down there in Texas, Dan and Jesse, but I can't wait to see Starship's launch today. How about you?
Yeah, can't wait to see it, Chris. As you can see, props loading on the vehicle is just a little under 2 miles away from us, and we're really excited. Looking back real quick, so back in March, Starship.
What a great view they have in that studio.
Saw us catch the Super Heavy booster for the 3rd time ever. Another big step on that path to full and rapid reusability. Unfortunately, the Starship upper stage did experience what we call a rapid, unscheduled disassembly before it finished its climb to space, which meant we didn't reach all of those additional mission objectives that we had set.
About 5.5 minutes into ship's Ascent burn, a hardware failure in one of its sea-level Raptor engines took out that engine, the 2 remaining sea-level engines, and
turbo
a
pump
Raptor
machinery
vacuum
possibly.
Engine. That's 4 of the 6 engines that ship has.
Or the combustion chamber rupture, something like that.
A failure than we saw on Flight 7, and the fixes that we put in place did work as expected.
That's awesome,
so
Toast.
This was a new issue on Flight 8. So welcome to iterative engineering.
That's right. Losing hardware is a potential outcome of any test program. That's why we're always prepared with safety measures in place.
Starship looks good.
And also ready to have boots
Starship
on the ground
V2 there looks super good.
Like
so you can see here,
we can coordinate with all
this is where tiles used to be. You see that black, more shiny bit? So they used to have tiles all the way across this section here. They removed those specifically because right here, actually y'all can't see that. There we go. So right here is the actual catch pin. So that catch pin is designed to fit inside of the catch towers, the rails, during a catch. And so you can see they removed all the tiles here, replacing it with fire retardant paint or some sort of other material here for reentry. So they removed the tiles there. So that's also something that they want to test for V2 Starship is, can Starship survive with fewer tiles on the side? Because, you know, it's a round body, and typically round bodies, you know, the heat, the stagnation point is of course along the bottom here, but the flames and the plasma and everything will absolutely lick up the sides. So we'll see how it goes. We'll see how it goes.
Super Heavy vehicle during its return to get data on.
Is it pronounced Rudd or Rude? I've only ever heard Rudd.
That we'll be pushing the flight envelope of Super Heavy as we fly at a higher angle of attack during descent towards the Gulf. Angle of attack in this case means that Super Heavy is pitched up to maximize drag and slow return. Because of this test, we will not be attempting to catch and recover Super Heavy, which again is
how close could you swim in the water?
I
don't know actually. I mean, not very. There's an entire keep out zone.
Will hold the title as the Super Heavy flight leader.
Like
All right.
I'm pretty sure they have like Coast Guard and stuff to keep anybody from doing that.
Let's get into it real quick with this
rapid
overview.
on orbit disassembly is a rude,
with a liftoff. 33 Raptor engines igniting.
Now I forgot to mention this. So we already talked about booster 14-2, second use of this particular first stage. Landing in the Gulf. Starship, once it gets on orbit, is not only going to doing an orbit relight of the engines for testing, but they're also going to test actual delivery of Starlink satellites on this vehicle. So they have a number of, there they go right there. They have a number of, I think, 8 dummy test Starlink satellites that they're going to deploy. And then they are going to land in the Indian Ocean. Total mission time is around like an hour and 6 minutes or so. And so they'll be landing on in the middle of the Indian Ocean, just I guess, what is that, northwest west of Australia. So it should be good. Should be a good flight. Hoping that they make it through SECO. If they make it through SECO, things are going to look pretty good.
Taught us new
Let's hope the
lessons
door
about
works this
Starship
time. True,
hardware,
true.
the Raptor engines. And as we touched on earlier, the root cause was traced to a hardware failure in one of Starship's 3 center Raptor engines.
Yeah, just since that flight, we've done more than 100 long-duration Raptor tests at our facility in McGregor.
Ooh.
Huge shout out to that team for really putting in the work to better understand what happened. As a result, the engines that are on Starship's upper stage on the pad right behind us have a few changes. One of the key ones we did was additional preload on some of the joints, essentially some additional torquing, a new nitrogen purge system for the engines themselves, and made some improvements to the propellant drain system.
After our first ever super heavy refurb campaign, we static fired with all 33 Raptor engines.
Oh, so nice,
This was a chance to see all the hardware operating together, and for this flight, our teams had an opportunity to make adjustments or hardware replacements for this first ever reflight of the super heavy booster.
And then it was ship's turn. We took it through several static fires. First, we did this short duration single engine burn to simulate an in-space reignition of Raptor using those header tanks.
So Starship 35 has had a little bit of trouble gearing up for flight. Hopefully they got all the kinks worked out now. But yeah, after some of the engine tests here on Starship 35, they actually had a vacuum optimized Raptor engine had a funny occur during shutdown, so they actually wheeled it back to the hangar, swapped out that vacuum optimized Raptor before wheeling it out for integration with the stack. So same thing with booster 14-2, if I'm not mistaken. Something happened, whatever it was, something minor, they wheeled it back into the high bay, fixed whatever they had to do, and wheeled it back out. So there's kind of been some logistics back and forth
because of how much faster that is, but just how much bigger Starship is. Falcon
How do you feel about hot staging?
Lift about 23 metric tons into orbit. Starship is designed to lift.
It's a well-known and proven operative mode for a rocket engine. It's not typical for American rockets, but it's certainly something that Russia has done. Soyuz does hot staging. And there's a reason why they do it, right? They need some sort of acceleration during shutdown to make sure Starship basically separates from booster and maintains controllability during that process as well. Because the vehicle is so massive, especially at higher altitudes. Because remember, separation actually doesn't occur that high in the atmosphere. So they're still dragging things like that working on the vehicle. Not only that, but they also use those gases to help rotate and spin booster for the boost back burn. So there's a number of positive reasons for doing hot staging, and you know, it seems to be working pretty well.
Ever develop or any rocket ever.
Is today the next Starship explosion? Well, hopefully not, but potentially. I'll say maybe. I'll say maybe. Hey, what's up, Misadventures? How are you doing? Yes, the stranger is back. Who is this person? What does he want?
First milestone, and that we have proven that we can recover a vehicle, turn it around,
so good.
fly it a second time.
So you can see the ripples, the sound waves moving through the steam there.
An ideal state looks like a vehicle where very few things have to happen on it in order to take back off again. So we catch the vehicle, put it back onto the launch mount, put a new ship back on top.
It is, if it works, it is a fast way to operate, chat.
And that same booster will come back to the launch mount, and we do the same thing all over again. Falcon is, reusing at a pretty high rate, and we get to go look at them and say, what did you learn? What is good? What is bad? And as we continue to build the Starship process.
Zero touch refurbishment really looks like a commercial airliner. The advantage we have on booster relative to when we developed Falcon
I know,
9,
right, Byte? I 100% agree. Yeah, we were talking about that earlier, Byte. I definitely, they're testing. It's understandable. SpaceX needs a win today, in my opinion. Not saying that their last missions haven't been wins. They've obviously learned things in their vehicle that they haven't otherwise learned. That's great, but they were failures at the end of the day. So I think SpaceX definitely needs a win here. It'd be super, super good to see Starship V2 fly all the way through re-entry, survive, land, but definitely at least make it to orbit or near orbit at suborbital trajectory. At least make it past the SECO stage would be super, super good.
Really the key goal of the Starship program.
Like, it might burn up on entry because they're testing new things with the heat shields, right? So cool that we haven't even been able to test yet. So maybe V2 Starship yet won't survive re-entry, but still, if they can make it to orbit or its suborbital trajectory, deploy the V2 Starlink dummy payloads and all that sort of stuff. If they could do that, That's going to be so good. It's going to be so good if they could at least get to that point.
The booster over 80% full on the ship. So
hey, Dr. Longballs, how you doing? Yep, I've been busy with life. There have been some things in my personal life that have taken me away from streaming. I'm hoping that those will be ending here soon, within the next month at least, and be back to streaming on a more regular schedule. But we're back for Starship. Got the time for Starship. We got to see it. So yeah, we're back for today.
Pretty smoothly so far this morning.
Yeah, been to space. Yeah, you know.
Booster ready for prop load, making sure guidance, navigation, and control are aligned. Everything's ready to go. You can see
16 minutes
coming off. We're getting.
I think the vehicle starts stuffing at around 4 minutes, right, Chad?
The propellants
Thanks,
on
Dr.
board
Longballs.
both ships about 45 minutes or so before launch.
Maybe Toaster. Maybe that's what we're working on.
We're going to continue loading these propellants on board until just about 3 minutes before liftoff. We'll close out on the ship first and then on the booster. But bottom line, everything's looking great. Not tracking any vehicle issues, range issues, weather issues. We're looking really good right now for a launch at the top of our window right at 6:30 p.m. Central.
Yeah, seeing the propellant loading is making this getting more and more exciting. Today is going to be a wild ride for Super Heavy. We're putting the booster through several tests to expand the envelope on its capabilities and get flight data to make its return and catch more reliable. Now, another unique change in today's flight will be the addition of the first ever directional flip of the booster.
That's right. If you've followed previous flights and you kind of wonder to yourself, why does the direction the booster flip seem random? Surprise, it's because it was.
The way the gases impinge on the first stage from Starship makes it flip in weird directions.
Different directions, and it was really small differences.
So like we were talking about earlier, that's one of the changes that they're making to the second flight of Booster 14, where they, awesome side-by-side. We can see the directions that it flips.
It'll react. The engines will gimbal.
Oh, looks totally different.
That was the easiest option technically.
Sideways, down, up. That's awesome to see side by side.
Every single
so that's what they're trying to combat with this modification to the hot staging ring. So we were talking about this earlier, right? Booster 14-2, the second reuse of this booster, has a side of its hot staging ring, the vents, blocked, in the hopes and the idea that as the hot gases from the Starship engines impinge upon the vehicle and those blocked ports, it's going to cause booster to flip in a determined direction. So it's no longer going to be random. It'll actually flip in the direction that ideally those ports deterministically allow. So that's really cool to see. The reason for it right there, side by side, the last three flights, the boosters, going flipping upward, flipping downward, and then flipping sideways. They're trying to eliminate that variable.
To accomplish this, we made some changes to the hot stage adapter, welding reinforced panels over the vents in the direction that we want the booster to go. So when the ship engines ignite, the thrust will push against the blocked vents, which means that the nudge will be in the direction that we planned for. And then when we go to the next generation of ship and booster, we plan to control the flip direction by fine-tuning the engine startup sequence on the ship.
Nice.
Yeah, that's not the only flight experiment that we have planned for the booster today. We're not attempting a catch, so we're going to try and gather
high angle of attack return. We talked about that.
Performance on future boosters. We're also going to try and see how resilient we are to things like losing an engine during the landing burn.
Nice.
By sending the booster out to sea, we're able to do these higher risk tests without risking the launch pad. As you might have heard earlier, we're going to be doing what's called a higher angle of attack. Basically, instead of coming straight down, we're going to tilt up a little bit. That gets you more drag on the booster. You're able to use just aerodynamic forces to slow you down. The slower you're going at the start of that landing burn, the less propellant you need.
We talked about all of this earlier.
Slowing down as much as humanly
They're playing catch up with us.
So by already going a little bit slower, we'll get some benefits to our performance and our reliability on those burns.
Yeah, exactly. And there's definite uncertainty in how well the booster's grid fins and structure will be able to control its flight when we get into higher angles. So don't be surprised if it isn't a smooth descent for the booster down to its splashdown point today. The most important objective
booster doesn't separate the whole vehicle, lands and floats. Yeah, exactly.
To help anchor our models.
Submarines.
Now we're hoping to fly the next generation of super heavy boosters at even higher angles of attack. So this test today will give us a better idea of what is feasible. Now, on top of all of this, we're going to see how resilient Super Heavy is to engine failures at the most critical times.
Yeah, nice. We're going to intentionally disable one of those 3 center engines and instead use an engine from the middle ring.
Let's just hope those hot staging ring mods don't damage ship. Yes. I mean, they haven't so far, so hopefully... Oh, I see. The modifications talking about the blocking. Yeah, hopefully it won't. I don't expect it to. The gases are still able to escape, but you're absolutely right. A change is a change, and we need to hope that those changes don't affect anything adversely. That's the whole... It's the whole balance with aerospace engineering, right? Is if you change something, you got to make sure it doesn't affect anything downstream of that change adversely. So hopefully they did the analysis. I'm sure they did. Especially after seeing, I'm sure, from previous flights, just how much pressure buildup there is from those escaping gases during hot staging startup. But yeah, we'll have to see. We will have to see.
Launch providers expend all of their boosters after flight. We land and reuse most of ours. All of these tests are going to help us improve future generations of Super Heavy until we reach its fundamental design, a fully and rapidly reusable and reliable rocket. All right, let's check back in with Chris in Hawthorne. How's it going, Chris?
Hey, Jesse. My colleagues here in Hawthorne definitely agree with you. We can't wait to see the Super Heavy perform its second flight and see all of the work from our thousands of engineers and technicians in action today. Now, while this reuse milestone is incredibly important for Starship's development, Super Heavy boosters are not the only vehicles that we reuse here at SpaceX. We're big on reuse, and our Dragon fleet is another example of that reuse. And we actually control those Dragon missions from right here in Hawthorne in the mission control room that we talked about a little bit earlier. For Dragon and our human spaceflight program, this month also marks a big milestone for SpaceX, our 5-year anniversary of human spaceflight.
Nice.
Now, NASA astronauts Bob Behnken and Doug Curley got us started back on Demo 2, which was notable for being the first time since the retirement of the shuttle program in 2011 that people launched to orbit from U.S.
Seems like a lifetime ago.
Now, in those 5 years, we have launched 17 human spaceflight missions, 11 for NASA, and 6 commercial missions, including Polaris Dawn, with our first commercial spacewalk in history, and From 2 earlier this year, which became the first human spaceflight mission ever to explore Earth's polar regions. We've flown a total of 66 crew in those 5 years, and we are expecting that number to grow significantly in the coming years. Now,
especially when Starship becomes human-rated.
The crew offered unique glimpses into the orbital spaceflight experience.
Can you imagine taking 100 at a time? How easy is that?
To see. Thank you to our Starlink teams for making everything with the From 2 crew shared possible. This honestly made me feel like I was right there with them in Dragon. They were living, they were working, they were relaxing, they were doing their experiments while also having fun. Basically, just being people and inviting us along for the ride. And that was really meaningful. Being invited up there really showed how these are just the early days on the road to making life multiplanetary. And the vehicle that's going to make all of that happen is
So in about
Starship.
6 minutes?
Dan and Jesse,
5 minutes. In about 5 minutes from now, we should have closeout at the propellant. So I believe propellant closeout for the Starship itself closes at like 3 minutes and 20 seconds to launch. And then we'll also have booster propellant closeout 30 seconds after that. At around 2 minutes and 50 seconds. So around the 3 minute mark, plus or minus, we should see closeout of propellants. And hopefully from there, they'll start stuffing the tanks and we'll see a good ignition.
First Starships to Mars as early as next year.
Yeah, this will help prove that we can actually get to Mars with a focus on learning as much as possible while demonstrating what will be needed for Mars transit and landing. But before we can make life multiplanetary, we have to build the starships that will make this all possible.
That's right.
Man, look at that tank farm, chat.
Right here, Starbase,
they have the recircularization going. That's the big venting process here.
Soon going to be launching.
They've expanded this. They've expanded the propellant loading capabilities.
And the place is changing every single day. We've grown quite a bit just in the last couple of years. There's a couple hundred employees, their families living amongst actual rockets. We're in the process of expanding production and integration. We've got a target of 1,000 Starships a year.
I mean, look at that. They've created their own
And recently,
town.
we did become a city of our own. We're the first city in Cameron County in 30 years. And that's just going to help us scale more quickly, try to build out the best community possible for all the people
Thousands
that are building the future
of workforce
of
employees there
place in space. Starbase pretty easily one of the most inspiring, exciting, unique places to live and work on the planet. As usual, shameless plug, we're always hiring. Come help us build the gateway to Mars. Visit SpaceX.com/careers. You can see all of our openings.
And this is my first time in Starbase, and Dan, the Star Factory is a manufacturing engineer's dream. To be able to build a factory like this at such a large scale.
Yeah, so Jessie there, she is an engineer. She works on,
so wild to me.
I want to say structures, but I don't remember.
Chris is hanging out right where I call home base, so let's check back in with Chris in Hawthorne.
Or maybe I'm thinking
Jesse.
Fireflies.
Yeah, everything here in Hawthorne is looking good. The crowd is gathered.
TV casters,
really excited
structures.
to watch the hard work of all of their colleagues come to fruition here for Starship on its
all right, chat, 6 minutes. On the Twitch side, I'm going to run a quick ad, so that way we don't get any ads during the actual launch, and for most of the mission on the Twitch side. So on Twitch, I'll see you guys back here in just a few minutes. Should be back way before we have launch, so I'll see you in a second.
Flight today.
Thanks, Chris. Now, if you're just now joining us, where have you been? But we're glad that you're joining us now. We are at T-minus just under 6 minutes until liftoff of the 9th Starship test flight. So far, the range is looking good. All the airspace and trajectory area that we
want to make sure we are live. Let's reload real quick. All right, there we go.
All right, yeah, it is continuing. We're a little over 90% full on our booster. We are
should have close out in about 2 minutes.
Ship, filling up those header tanks. We're going to continue loading prop for about 2 more minutes. Once we're done with that, you've got just under 11 million pounds of liquid propellant spread across those 2 stages.
And it's crazy. Those 11 million pounds, or like 5,000 tons or whatever, are completely filled in 45 minutes, roughly. 45 minutes to exchange or to push 5,000 tons or 11 million pounds. So, like, absolutely wild.
We're doing final alignments of the guidance, navigation, and control system, our thrust vector control, essentially our steering, checkouts of the flight safety system. So everything progressing right now.
We got cams on Turks. Yeah.
Do need to hold, that can come at T-minus 40 seconds. That's a point built into the countdown where we can pause to wait for any final checkouts, pressurizations, anything that we need to complete. We can hold there. We will only hold there if we're tracking an issue. We're not currently tracking anything that will hold us at T-minus 40 seconds. But if you've seen a Starship launch before, they can happen. We can push through them and then launch that day still.
Exactly. But when we do pass through T-minus 40 seconds, a number of events will occur in rapid succession. The ground spin and ignition systems come up to flight pressure, ship goes to internal power, and then after that, the quick disconnect or QD, arm lockout is removed in preparation for retraction just shortly after T-minus 0.
All right, chat, 4 minutes.
Once we pass T-minus 40 seconds, we do still have the ability to recycle the count under certain conditions back to T-minus 40 seconds, and then hold there to assess what happened and see if we can proceed again back down to T0.
Yeah.
Let's see what happens.
Things,
fingers crossed.
Gates in that timeline that if we pass through that and we hit a hold, we'd have to scrub for the day. One pretty visual one will be if the water starts flowing for that deflector system that's underneath the launch mount. That happens right at around T-minus 10 seconds.
All right, right about now we should have Starship close out for prop load.
And if we hit a hold, we're scrubbed for the day. We would need to refill those water tanks. We would also
listen for the call out if we're on the countdown net.
Propellant tanks is 11 million pounds of propellant. It's a whole lot. We can typically do that in about 24 hours, so we can always turn around to try again tomorrow. But we are coming up on 3 minutes away from liftoff. We should be hearing that we're closed out of prop load on the ship at this point. Booster coming up shortly.
Booster closeout of prop should be about now.
Weather just looks amazing there with Starship on the launch pad. Just about 2 minutes and 45 seconds from T0 with a lot of objectives for today. The booster, the Super Heavy booster flying today, will be flying for its second time.
We should see closeout. It looks like the vents did in fact close out on the vehicle.
And just turned around.
There's the big purge
2 flights, which
right
is
there. So they're purging
incredible.
the lines going up through the tower that's filled with liquid oxygen. They're purging those out, removing also any methane from the system back down into the tanks. So yeah, 2 minutes chat, we should be good. Yo, Captain Failure coming in for the 49 Kerbal years. Much love to you, Captain Failure. How are you? Yo, what's up, Warlock? How are you?
We eventually have to start looking at our temperature of all of our propellant on board. That's usually what drives us.
All right, remember the next major milestone is the flight director verifying go for launch.
40 seconds.
We're expecting a hold, they said. Okay.
Sounds like we're going to be doing some additional checkouts on the booster Raptor while we're at that T-minus 40-second mark.
That's fine.
So we will expect to see the clock pause at T-minus 40.
So they were just talking about that at T-minus 40 seconds is a built-in hold, basically milestone or gate, where if they're tracking an issue, they stop there, try to work the problem, and then they can continue with the count. So this is fine. This has happened on, I think, the last flight, actually. I think Flight 8 actually had a momentary pause at 40, but then they were able to just push on through after a moment as well. Or maybe that was Flight 7. But it's happened before, so we'll see. T-minus 40 seconds, though. We're expecting the countdown timer to pause. They're going to work whatever issue that they're wanting to work out, and we'll see if we can go.
And as Dan mentioned, we will be holding at T-minus 40 seconds, so in about 20 seconds from now.
Yeah, so we'll hold there, and they'll work through these final checkouts on...
They might not even be working an issue, just a checkout
on the first
issue.
Stage on Super Heavy.
Just making sure everything is good before launch.
Said, we're reflying it for the first time. 29 of those 33 engines have already been used in a launch, one of which has already
There we go. We have our pause.
Twice.
And they have a pause button. I don't know if I've noticed that before.
And you just heard our flight director for the day.
Can I click the unpause button?
He just shared that we are going to hold at this T-minus 40-second mark. Keep an eye on one of those Raptor engines on boot.
All right. During this hold, I'm going to make sure we're caught up with the live stream. All right. We'll see if they can work this checkout, if they're tracking an issue, or if they just want more time to verify something that they're seeing. They have a new UI, yeah.
And if you're just now jumping in, we are holding still at T-minus 40 seconds. Watching one engine, waiting for temperatures to
something I always like to point out, chat, during ignition, and especially as the vehicle is pulling away, look at the condensation here on the ground. You'll literally be able to see the pressure waves from the engine reverberating through and disturbing the condensation. You'll like literally see the waves, the pressure waves moving through the condensation, which is really cool.
We held for a while on the first attempt last time and then cleared it, and then we triggered a different issue on the ground side.
But again, this is exactly what it's for. This gives us the best chances.
So you can see they're doing pressure management, opening the vents here. Oh, there we go, chat. 35 seconds. Here we go.
All right.
We should have launch countdown.
30.
Launch director going go.
Watch that first flight proven Super Heavy. Get ready to take off.
Flight director is go. All right, chat. Tracking no issues. Flight 9. Fingers crossed we make it into orbit. Well, suborbit. 10 seconds. We're looking for 33 by 33 on the ignition on first stage engines. We have a hold. We have a hold.
We did have a hold. And
all right, recycle.
Like the clock jumped back to T-minus 40 seconds.
All right. Well, we'll see. Womp, womp. Yep, indeed. A big old womp, womp.
All right. So, yep, we jumped out. I did not see the deflector go off. So hopefully we were right at around that T-minus 10-second mark.
And if we were before that T-minus 10-second mark, we do have the ability to recycle, as we mentioned earlier, back to T-minus 40 seconds.
So we're still
so it looked like
good.
This time it was a ground side issue. We're taking a look at this real quick. So again, we're going to...
Ground side issues are the worst
for a little bit.
Because they're almost never something that you can fix from the control room.
Still not scrubbed for the day.
Like if it was an actual Starship or booster problem, you can like recycle the count, you know, recycle the system, go through your checkouts again, and then launch. But if it's a ground side issue, like a sensor's not cooperating or anything like that, then the only way to fix it is by going out there, swapping out the sensors. So that would be a done for the day. Ground side issues are the worst, chat.
And you do want to make sure your temperatures
send in
really
the red team. Yeah, not to this thing. My goodness.
A healthy startup on Raptor engines. So
I couldn't imagine.
They're going to work through this issue. We can continue to hold here for a couple of minutes. What's launch without a little extra added excitement?
A little added excitement. Yeah, the anticipation, it's killing us, chat.
All right, so cumulatively, we've held for a little over 3 minutes between the two holds. Again, this is a ground side issue on our tower. The techs are looking through the data right now to see if it's something that we can either
ground side issues are the worst,
or if it would cause us to have to stand down. So we're continuing to hang out with them.
Every time. It's always a ground side issue, right? No matter the company. SpaceX, ULA, Blue Origin, I think. What was it, Blue Origin that also had a ground side issue? I don't know. They're just always the problem.
Joining us, we did initially hold at T-minus 40 seconds. We continued the count, but we cycled before we got to T-minus 10 seconds. And so we're back at a hold at T-minus 40 seconds, waiting for more information. The team is checking out.
Just deflating, chat. Just deflating.
Today.
Could it be someone in the restricted area? I don't think so. They came on the loop saying that it was a ground side issue. So I mean, I guess
we're continuing to hold
technically
here at T-minus 40 seconds.
Could mean a no. Typically for somebody going through the restricted area, they'll actually say like range is not green. It's a range violation. Now they said it was a ground side issue, meaning a ground support equipment issue.
All right, so it sounds like we're coming to a resolution.
Which is not to scrub. The resolution is to proceed anyways, right? Right? How can they hold it fueled up? Well, that's...
Oh, all right,
reset.
So we are...
I heard that
getting to a resolution. We're going to reset everything.
Maybe good. That's kind of what they're working with. There's a timer, Misadventures, on just how long they can stay here without continuing to refill the prop. And most likely they wouldn't just refuel prop, because then that puts everything through a variable operating condition that you do not want.
So we're going to see the clock. It is now rolling.
Okay. 35 seconds, round 2, chat.
We saw an issue with that quick disconnect to the ship.
All right.
There is a chance that automation will kick us out again if we encounter the same issue. But for now, the clock is rolling.
Fingers crossed, chat.
We pass around that
eyes crossed, whatever you got to do. It was at 10 seconds. We got to make it through 10. There we go, ground deluge. Oh, there we go. We have 33 Raptor engines. Look. You see the pressure waves moving through the condensation? Oh, that's so good. And she's flying. 33 Raptor engines on the first stage, and we are already 200 meters off the ground. A skyscraper taller than Saturn V and Artemis flying into orbit. Oh, the sound, chat. Oh, the sound is so good. All right, vehicle is rotating.
Avionics power, telemetry nominal.
Telemetry nominal, avionics nominal.
Right over top of us, we see 33 out of 33 Raptor engines.
Oh, look at that. They have the IR camera.
To ascend skyward.
Oh, that looks so good. All engines, baby, on the first stage. All right, we should be hitting max Q right about now.
Coming up on maximum aerodynamic pressure, then only about a minute and a half until
we go,
get
max
into
Q.
hot staging.
We have about another minute and a half on the burn for first stage.
Incredible.
Was that their windows rattling? No idea, honestly. I have no idea, Naps. It could have been their windows.
The
vehicles pitching downrange. Vehicles pitching downrange. Oh, look! There you can see the functional guide pins, the actual catch pins on the side of Starship here. So this is a camera on the top of Starship on one of the flaps, I believe, looking down.
A little under a minute.
We have about 50 seconds remaining in the burn.
All but the 3 center engines turn off.
What wasn't rattling, indeed?
So our version of Miko,
look at that!
And then just a
so
few seconds
clean.
Later, to see 6 engines ignite on ship to push it away.
Nice. Yeah, so remember, Miko for Super Heavy does not mean main engine cutoff. It means most engine cutoff. They go down to 3, I believe, while Starship ignites in hot stages. And then the 3 engines are gimbaled, so they can do their controlled boost back burn. And then they ignite, I believe, up to 13.
And definitely keep an eye on which way the booster flips. First ever directional flip we're going for today. Should flip
All right,
straight
another
up.
10 seconds, chat. Hot staging should be happening here in 10 seconds. Look for 6x6 on Starship engine ignition. Yep, it's rolling.
Cut off.
There we go. We're down to 3. See it? Down to 3.
Ship ignition.
And we have good. Oh, and look, it flipped. Oh, that looked good. If that was the right way to flip, that looked really good. We have 6 engines on Starship.
Super heavy booster, and you can see those.
And we have the boost. Oh, look at that!
On the ship ignited.
That's super heavy, or not super heavy. That's Starship in the background.
6 healthy Raptors running
look at
on
that!
Ship on its way to space.
Very clean.
View,
very clean.
Boost back.
Solid.
Chris, how's it looking over there in Hawthorne, man?
It is looking.
Chamber pressure's nominal.
Chamber pressure's nominal.
Absolutely incredible here in Hawthorne.
Awesome.
As we said, 6 healthy
Absolute
engines
perfection
on ship.
indeed.
We've got 13 out of 13 engines on the booster. Now down to those 3, which is what we expect.
Should have
in the
hot
final
staging ring
moments of the
jettison
boost
as well.
back burn. Now, as a reminder, we are not recovering the super heavy booster today. We are instead going to do some.
Shutdown.
And there we had a good shutdown of the boost back.
There
burn.
it is. Hot staging
Next up
ring
will
set.
be the jettison of that hot stage
Nice.
ring.
Avionics power and telemetry nominal.
All right, now we
Great
should be
call out there that
about
everything
2.5
looking
minutes
nominal
away
aboard
from
the
super heavy
vehicle,
landing burn.
which is returning to Earth, and we're going to be doing some experiments with it, including a higher
Starship
angle of
is looking
attack
good. Look at
re-entry,
Earth in the
as
background.
well as some engine tests
so
as it gets
good.
closer to
Camera views
the
from
Gulf. We
SpaceX
are, again, because
never
of these tests
cease to
not recovering
amaze.
it, we are sending it to the Gulf on purpose to do those tests. But again, you see the booster on the left-hand side of your screen. You see ship with 6 healthy engines continuing its ascent to its
So
planned
remember,
set.
around 4 minutes from now is when Starship has repeatedly had their last 2 failures. So around the 8-minute mark is when Starship has had failures in their engines. So we'll see. We're getting good pictures of the
aft
Starship engine bay.
area of ship. They're looking at those 3 sea level and 3 Raptor engines on the right hand
Look, you
side
can
of your
see
screen.
you can see Raptor engines
Booster
encased
doing its
now.
LOX dump, that liquid oxygen dump. So because we don't need some of that liquid oxygen propellant in its tanks, we vent that propellant out to lessen the booster's mass as it comes in.
See how flat
for
it is?
its
Yeah,
landing.
totally. 100% super flat. Confirmed, chat. Hey, what's
Just
up, Juan? How are you
absolutely
doing?
Gorgeous views watching these 2 vehicles do their respective things.
If you're talking about this right here, this is fine.
And Dan,
As far as I'm
approaching the
concerned,
5-minute
this
mark
is fine.
into the flight.
It
Super
looks like
Heavy
it's
is descending
a
rapidly.
vent maybe right there,
What
and
can
that
we expect
vent
here in the
is
next few
just
minutes as it
igniting
does
because of the
temperature
hot gases. We'll have to keep an eye on it though, but it looks okay.
Now, as we had talked about, Super Heavy might not have a very smooth ride down. We're going to be putting it through this higher angle of attack. So we're kind of pitching it up.
Definitely going to have to keep an eye on this camera angle
We've
though.
done this in wind tunnels. We've done this
Vehicles
in
pitching.
computer modeling. It shows that sometimes the control isn't great, but only one way to really prove it out, and that's to get real world data. So here comes Super Heavy.
Predator burn outside. Yeah, that's
It
true.
should be igniting for its landing burn.
Oh, look at
in
Starship roll,
just
chat. Awesome.
About 40 seconds from now.
And we are going to
Nice.
relight 13 engines. Then
Look at
bring
that.
down
The hot-
to 3
the hot
engines,
forbidden
as
pizza,
as
chat.
we talked about earlier.
The
We
hot
won't be
forbidden
intentionally
pepperoni
shutting
pizza.
down. We will be shutting down
Should have
one of
landing
those 3 center
occur
engines
in about 20 seconds.
to push the limits of the super heavy booster.
Ship Raptor chamber pressure's nominal.
And continuing to
Oh, look
see
at it. It's
6
hard to see in the
healthy
camera, but look at the
engines on
the
ship,
telemetry. Look at that angle it's flying at. It's flying like this.
Still ignited.
Coming in somewhat sideways.
Its way back down to Earth.
We can see those grid fins doing some heavy work.
Booster landing, start up.
Ignited for our landing burn.
No? Question mark? No. No. Negative, chat. We are 10 seconds.
With that landing burn.
Yeah, we did not reignite. Reignition for landing
like
should have happened at 6 minutes and 19 seconds.
Once we started into that landing burn.
And it's gone.
Did you see a confirmation that the booster did demise?
Well, that was exciting.
So the booster's flight ending before
very
it was
much
able
a poof. Yeah, that big fireball
again,
there.
We're not bringing that back. We're expecting it.
Well, it's okay. This was a reused booster testing new things, so they learned something. Chat. They learned something during that process
through that high angle of attack flight. So that was something that was really vital for us to get during this reuse. First reflight of booster in the books.
40 seconds.
Right,
oh, look at that. Get a little hot spot right here. A hot spot those on the outside, so that's fine.
About 2 minutes, we expect.
But we'll have to make sure that hot spot doesn't grow and get brighter, meaning it's actually from the inside.
Seco.
But you can definitely see a little bit of a hot spot right there on the cowl or on the nozzle extension.
These are some incredible views, Dan, from the aft end of the ship, watching as the engines stay ignited with the Earth in the background.
It's looking
As
good
always, the
so far.
Starship avionics team, the techs.
So flight test 7 started its first failure right around here.
I think we just heard the booster.
Oh, look at that.
But
that's from the boost back burn.
About a minute left into this burn.
You can see the trails from the boost back burn.
As we get through the final stages.
All right, it's already made it. It's already made it past flight test 8 failure point. That's good.
In about 45 seconds.
And at around 8 minutes and 56 seconds, we should have SECO. So it's only got to make it another 30 seconds or so. That hot spot is getting brighter, though. But, again, should be fine.
All right, just about 30 seconds to go. We're in terminal guidance.
Come on,
Final
baby.
Stages of this Ascent burn.
There we go, shutdown.
See shutdown of the Raptor engine.
Nice. We have 3. We're still igniting 3.
These, so we do the Raptors first. Those 3 have shut down successfully. Sea levels still running.
Looking good. There we go.
Ship engine cut off.
Good shutdown. All engines. Awesome. Brilliant. Brilliant. There we go, chat. Oh, man. So it's made it to suborbital flight.
Most beautiful words in the English language.
And great call out that we had nominal insertion.
Good. Good. Hope you see some debris from the heat shield or whatever they have on the top part of the engine bay.
Test so far today.
Venting looks good. Okay.
Flew
awesome.
A super heavy booster.
Well, next thing should happen pretty quickly in about 10 minutes, less than 10 minutes. We should have payload deployment.
In its orbital trajectory.
Is it tumbling?
Again, it's going to remain suborbital for its mission today.
It might be rotating.
It
doesn't look like it's tumbling, though.
It ignited all
Here's
6
the
of its
attitude
engines
telemetry.
And made it all the way through SECO just now.
But it might be rotating long axis. Or short axis, rather. It is rotating a little bit. I don't think it's in an uncontrolled tumble.
Incredible.
All right.
Nominal insertion. Okay, Chad. Well, that was the hard part. That was the hard part.
Per usual,
yeah, see, it's rotating like this along its short axis.
How's it going over there in Hawthorne, man? How's everybody doing?
I think the elation and the excitement and the happiness at what...
A big ol' exhale, chat. They have made it beyond their last 2 failure points. This is the first Starship version 2 or Block 2, making it into space through second engine cutoff, through SECO. Like we talked about before, their last 2 flights of this vehicle ended in failure due to hardware failures and design point failures. So they're in orbit, or well, they're in their nominal orbital insertion, I should say. Still on a suborbital trajectory, but nominally so.
Starbase, 33 out of 33 Raptor engines lit on the Super Heavy, all 6 engines lit on ship, bringing it to its planned suborbital.
I don't know for certain, but I can only imagine it's rotating like that, so that way when they deploy the Starlink dummy payloads out of the PEZ dispenser, they get separation from the vehicle. Okay, for a second I thought it was arresting the rotation. But we see that in all of the transporter missions and when there's rideshare missions and also actually for Starlink missions for Falcon 9. So Falcon 9 upper stage does the same thing. It rotates along its axis so that way as it deploys payloads, they get good separation from the vehicle.
New heat shield modifications to Starship, and that'll start with re-entry into Earth's atmosphere at about the T+45 minute mark, which should take about 16-18 minutes to
complete. But overall,
complete.
It's holding a good attitude. The attitude's not changing very much. It's only rotating in the in-plane from this diagram.
100 missing heat shield tiles on its thermal protection system. Now, we purposely took those 100 tiles off over very critical areas of the vehicle to be able to safely test on a flight like this suborbital trajectory into the Indian Ocean.
Very nice pictures, yeah.
What might happen on an operational flight in those areas if we were to lose the primary heat shield tile over Starship. So very critical test coming up. And then after that, we'll have the final descent where we will again be pushing Starship to its limits. We definitely pushed the booster to its limits today to gather data, and we're going to be doing the exact same thing.
But she's in space,
ship,
chat.
Seeing how the ship handles various flight conditions that we will need it to fly in as we look to one day soon bring ships back to
She's going over the Caribbean right now.
Reuse. Now, while there are payload simulators on Starship,
it's venting a lot. Yeah, it vents a lot
today,
for sure.
As we will see in a few minutes,
it's got a lot of pressure management to handle.
The primary payload for today is the data. And today, just like with Starship's previous test flights, that data is coming to us courtesy of our Starlink network. In fact, it is from Starlink that you are seeing these wonderful views of ship in space
for
now.
V2 Starship, they actually upgraded the Starlink terminals. I think it now has 4 Starlink terminals, higher bandwidth and everything, like their newest Starlink terminals for telemetry. So that's how we're getting all these camera views. That's how we're getting good telemetry. Is through Starlink, which is actually really cool.
Deploy. What can we expect next here in the next few minutes?
We don't have a fuel gauge anymore. We do not have a fuel gauge anymore.
Just going to reiterate, thank you to the Starlink.
It's practically empty. I mean, there's
incredible views.
Less than 10% fuel remaining.
In a few minutes,
based off of previous flights.
Deploy 8 Starlink simulators, similar in size to our next generation.
So that should be coming up in about 5
satellites.
minutes.
The Starlink simulators will be on the same suborbital trajectory as Starship, meaning they will passively re-enter the atmosphere, just like Starship. With tests like these, we can see how Starship's payload deploy systems work in flight while ensuring that the
do they have an internal view of the PEZ dispenser?
No safety risk to people
That'd be really
on
nice
Earth
if they have an internal view.
Other satellites in orbit. Now, this also ensures that any parts of these simulator Starlink satellites that do survive re-entry splash down harmlessly in the middle of the Indian Ocean.
And then before we get there, though, we're going to have to open up that payload deploy door. So we've only ever done that one time before.
Given them trouble?
Pretty sure it was Flight 3. Someone on the internet, please check me. But that was the only time we ever opened it. And we've had Starlink simulators on the last 2
it did have banana cam.
But we haven't gotten to this moment yet where we're able to open up the payload door and start deploying these.
Great view.
It's going to be pretty cool. We've got them stacked
from
inside of the
top
Starship
flap.
payload bay.
Looking at the flap.
We'll have potentially a couple of views. You saw one camera
There we
pop
go.
Up. There we go. Look inside
Look
of
at
the
that.
payload bay of Starship. You can see them stacked down in the middle of your view. There's kind of 4 on either side, so they're sandwiched on top of each other.
Vapor.
Stack of 4 right behind each other.
It might be vapor actually on the inside.
Pop the door open. It's on the right side of your screen, so we'll
that
see
is a great shot.
Up,
so there you can see the V2 Starlink dummy payloads. They're basically 8 like aluminum structures, like aluminum pallets that are just meant to simulate the mass of 8 Starlink V2 satellites.
Once that payload door is open, about a couple minutes later is when we will start dispensing those Starlink simulators. What a great view.
At the bottom of the stack.
Look at that.
So
look, this is the PEZ dispenser.
Be able to see them
so
firing out from right
they come down,
really
right?
Cool.
And then on the track, they get pushed out. Like a PEZ dispenser. It's really cool.
Next generation of Starlink satellite into space, and those are going to enable some truly insane things in terms of speeds from space and what we're able to do.
Yeah, it is. It is, Arax. That is the shot
really
right
great
there.
For Starship, obviously. Getting live video back is really cool, but just the amount of high-speed telemetry.
So there you can see the top of the dome right there for the propellant dome.
Development program, that's kind of.
What is that? The Methalox dome. Methane is top on Starship. Is that right?
In excess of 130 or 160. My numbers are fuzzy
right now. That's the top of it right there.
My brain is. But
we're inside the payload bay.
Well in excess of 100 megabits per second of downlink, and a lot of that gets eaten up by video. We've got dozens of cameras across Starship. We added several more.
Nice.
For this flight,
Good.
You saw a couple of those.
I want more.
We have essentially 360 degrees. Oh. Open the pod bay door, Hal.
All right, we should start seeing them eject in about a minute from now. About a minute and a half from now. Yeah, Hal, open the Pez dispenser, please. I'm sorry, Dave. Can't do that.
Now we are expecting the payload door to open any moment now, so we're watching out for that. Again, you're
Which
looking
side
at
is the Pez dispenser door
of Starship as it's suborbital.
I don't know if the Pez dispenser door or the payload door is this way or that way. Oh, well, we definitely can't tell now.
We heard the door open was in progress.
I was about to say, it looks like that's it right there, right?
It was unable to actuate all the way open, so they are going to close it back up. Hal told me no. He said, I'm sorry, Dan. Can't do that.
All right, so no payload deployment.
Looks like we won't get the door open today.
The door is still not functioning.
But that's okay. This is obviously a test we want to be able to do before we're deploying full-on Starlinks. But the real focus for this, now that we are in space, is getting to that reentry. That
all right,
is
so no payload door,
critical phase of Starship.
No payload deployment. Bummer, chat. So that is the first orbital test.
So it does look like we're not going to be able to deploy Starlinks today, but we should have pretty frequent views from Starship. They might cut in and out every once in a while, but should be pretty regular. We are in darkness right now, so might be a lot of black, but the cool part is when we get
look at everyone watching. That's awesome.
Yes.
Those are all SpaceX employees, or at least for the most part.
Some live daytime
maybe a few
views
guests
as ship is returning back to Earth.
All right, so we are going to take a break. Enjoy these views as we get them. Enjoy the tunes. We'll be back in a couple of minutes when we get ready to relight one of those Raptor engines on orbit. See you soon.
Raptor relight should be happening in about 20 minutes from now. A little bit, like I think T plus 37 minutes. So we got a little bit of time. We got about 20 minutes before the next phase of the flight, which is they're going to do a basically an orbit change maneuver, a test where they're going to be reigniting one of the Raptor engines in orbit to make sure they can do that, to see how the performance is during startup and all that sort of stuff. So that'll be happening in about T plus 37 minutes. So still got about 20 minutes or so. Of all the things to go wrong, you would guess that a door would open. Yeah, exactly, Trav. You most certainly would. You most certainly would. So much dust makes you think about ISS cleanliness. Yeah, but also spacecraft that go to the ISS are not built in the open in dusty Texas. Yeah. Starship is changing the game on how systems are constructed on this scale. But like you think Dragon and stuff like that, they're all built in a clean room. In fact, the clean room, I'm trying to remember, I think the clean room is like right here. Unless SpaceX has moved it, because this is all like engine assembly, and then way in the back here used to be the clean room. I think it still is the clean room back here. But yeah. So like Dragon and everything is still built in the clean room. So definitely no dust like that. But even still, you can actually see during deployment of Dragon on the forward-facing cameras, the same thing, like dust everywhere, condensation, whatever it might be. What are those particles? Certainly dust, condensation. Because remember, on the inside of the cargo bay, right, is the forward methalox dome, or the forward methane dome. Methane is cryogenic. When the when on Earth, under pressure and under normal temperatures on the ground, condensation builds on that forward methalox dome, and as it goes up into space, it will freeze and then fall off and all that sort of stuff under vibration. So it could be ice, it could certainly be dust, is certainly dust. Yeah, it's dirty. I do wonder why the door wouldn't actuate fully. Yeah, I would have to assume Ascent related collateral as well. I think this is a good way to describe that warlock. Yeah, so the door not opening, not a big problem. Obviously, they have many things that they want to test in this flight, and they're learning every single time that they test these things. The door not opening could very well be from the vibrations of Starship. It could be very well due to the temperature fluctuations and the steel doing, certain, morphing in certain ways under the launch loads. Yeah, there's definitely a lot of problems with any sort of actuation. You would think a door very simple, but also at the same time, when it has to be flush and handle launch loads and all that, not so easy. Vibration shaking stuff loose. Yep, could be a whole number of things, especially with, you guys have to remember, right, SpaceX with Starship, it is taller than Saturn V, and we all know from the stories of Apollo astronauts, pogo oscillations and how bad they were under Apollo. Pogo is the side-to-side oscillations that occurred during launch. You basically have thrust, a force at the very, very far bottom of your basically skyscraper, and what that does, especially as they gimbal, causes fluctuations to move and propagate throughout your entire structure, to the point where you basically have Starship doing this. I mean, I'm obviously exaggerating, but Starship is doing this at the very top of the vehicle at different frequencies. And so yeah, you better be sure that you better believe that anything is going to just be magnified. Any sort of small loads, the side force loads and oscillations are going to be magnified at the top of the vehicle, which is where the payload bay is. So yeah, they got some things to work out. They got some things to work out for sure. Can we assume that they factored in re-entry with and without the payload on board? Yeah. I mean, don't forget that Starship in its design is technically, I mean, at least from what they're touting, SpaceX has been building Starship to not only be able to carry 100 metric tons of payload into orbit, but also land with 100 metric tons of payload. Right? Like they want to land on Mars with 100 metric tons of payload. They're touting that anyways. I think they have a very long way to go before they can achieve that, but that's what they're kind of designing Starship to be able to handle, to my knowledge, unless that's changed. So yeah, this is only 8 V2 Starlings, which I think is on the order of like 5 tons, maybe less than 5 tons. Like, it's not a lot. It's not an egregious amount. So yeah, this payload in terms of the overall size and mass of Starship, I don't think is going to be a problem. And that's also why they have the flaps, right? What's great about Starship's design is that they use the flaps in order to be able to change where the center of pressure is, so that way they don't have to worry about balancing, so to speak, the mass in the payload bay, right? Because you can change your flap deflection, and as you change the flap deflection, you change where your pressure line is, your center of pressure, where you can always remain stable just by bringing it up. It makes it more back end heavy. Bringing the flaps down, it makes it more forward end heavy, so you can always balance out the crap. So yeah, theoretically speaking, it should totally be accounted for. It's just a matter of whether or not they already have that system in place to account for that in their guidance, navigation, and control. But I would assume they do. I would certainly assume that they do if they're already putting payload on board. I'm refreshing Reddit furiously to see if anyone has posted booster run footage. Yeah, we can definitely also go into x.com to see if there's anything from there. Oh, hey, look at this. I mean, it's from Scott Manley. It's just from the actual flight, right? But this is the live stream. This is what we saw. Definitely a pop, chat. Definitely 100% a pop. Let's see, do we have anything else in particular? Nope, don't see anything on X just yet. Nope, nothing on X just yet that I can tell. But yeah, I'm sure soon, chat. I'm sure soon. Any other pictures and stuff from it? Question mark? Nope, doesn't look like it. Oh, was that one? Nope. That was from NSF. Not yet, chat, not yet. So yeah, we'll have to see if there's gonna be posts of that explosion of booster. NSF hasn't had it, gotcha. Yeah, it might be too far downrange for sure at that low altitude that it would have occurred at. Because doesn't booster engine like landing burn start when it's only like a couple kilometers in altitude, if that? Like I'm trying to remember, like Falcon 9 landing burn, I want to say is within a kilometer, right? For the landing burn, of course, booster requires a little bit more time to slow down, but yeah, still, if you're even just 100 miles off the coast and you know, a kilometer in altitude and you're starting your landing burn, you're not gonna be able to see it. Booster had the run at startup, so Raptor, possibly, for sure, yeah. I don't know, we'll have to wait and see. Hopefully they give us some information in the future on what caused Booster's failure. But yeah, my go-to is definitely some sort of hard start, because remember, this vehicle was testing a high angle of attack re-entry, something that's never been tested before for Booster. And also this was a reused booster, so who knows what sort of other structural integrity issues Booster 14-2 could have had just from being reused and going through entry and landing beforehand, right? But that high angle of attack, meaning that it was creating more drag at different points of the vehicle, definitely could have started an issue, and then during startup caused, because we've seen beforehand, right? If you guys remember, was it flight 5, like the first like landing and or the first entry and whatnot, we actually saw the Raptor engines on the first stage all crumpled just from the aerodynamic forces. So yeah, if it's flying under at a higher angle of attack, getting more drag, and it's, you know, getting more drag at a lateral displacement from the direction of the engines, right, pushing the engine sideways, definitely could have hurt something on the actual engines. But yeah, we'll have to hopefully see the official announcement on whatever problem that could have been. You mentioned it should be able to land with 100 tons, but I imagine not on Earth. Yeah, I'm not sure, Goopin. I'm not sure what their Earth metrics are for that. For if I recall correctly, ooh, nice. We're getting some pictures back. Is that pink from Sunrise? Is it already over? No, there's no way it's already on Sunrise. No, okay. Because they want to be able to land 100 metric tons on Mars, right? And from... It's tricky to equate that to what it should be for Earth, right? Because Mars, right, doesn't have the atmosphere that Earth does. So on Earth, arguably speaking, landing higher mass things is actually easier because you can use more of the atmosphere to decelerate faster. However, because the atmosphere is denser here on Earth, you now have to worry about having a lower ballistic or a higher ballistic, mass over CDA, a higher ballistic coefficient vehicle going through entry, right? If it's a higher ballistic coefficient, it takes more heat screaming through the atmosphere because it takes longer to slow down. So if you can get over the thermal issues of having higher mass and you can actually decelerate more in the atmosphere, then technically speaking, it should be easier to land higher mass payloads on Earth. But then of course we have higher gravity, so then that kind of balances out. Yeah, don't know how it equates on what 100 metric tons, on what the actual payload to Earth should be versus payload to Mars. But for Mars, you definitely need more propellant to land because you need more propellant to decelerate because it doesn't have as much atmosphere. It's a crazy thing. It's a crazy thing to think about. But regardless, going back to the whole original plan, right, is that these 8 V2 Starlink dummy payloads should not be a problem. Shouldn't be a problem for entry here. Yeah, exactly, Goopin. And it's also interesting to think about that, you know, SpaceX pitched Starship to do point-to-point landings, and I don't know how much they were touting that they could do point-to-point landings for the United States Air Force and Army. Let me see. Starship point-to-point Earth payload. Do they have numbers for that projected? No, not that I can see anyways. It says 100 metric tons to LEO. It doesn't say anything about down mass capabilities. But yeah, don't forget that SpaceX did propose Starship as the United States Space Force's point-to-point Earth delivery, which is kind of crazy to think about. Yeah, it is tumbling. But again, it's so hard to see in this degraded camera because it is still at night. So the altitude still looks good. Speed is nominal. Oh, is it actually tumbling? Because you would think, depending on the way it's tumbling, that you should see space at some point. So is it actually tumbling, or is this pointing down and we're seeing like clouds on Earth pointing or going through? I don't know. It's kind of weird, this camera angle, I'm not gonna lie. Because it does look like it should be tumbling, but also, where is space? Or is this just all artifacting from the camera? I'm not sure. Oh, telemetry made it look like it was? Yeah. Gotcha. Well, we'll have to see. They should be coming back in about 5 minutes, where it should do its in-space reignition of Raptor. So they're gonna do an orbital maneuvering test. Just a very, very quick startup and shutdown of the Raptor engine. One Raptor engine on the system here. So we'll have to see if they say anything. But I find it odd that if it is tumbling, that we're not seeing pure blackness of space coming up every so often. I don't know. Yeah, it's going through a wormhole or something. Yeah, they removed the attitude gauge. Yeah, does it have it back here? Oh, there it goes. Yeah, it's just weird depending on which direction this camera is facing. Because if it is, I mean, the telemetry does look like it's tumbling, but if this camera is facing up or down, we should see the blackness of space, right? So like, what is all this? Is this just all camera artifacting? All of these, like, what look like clouds and stuff? But yeah, I have no idea. I have no idea. Yeah, I got you, Captain Failure. All right, we're about 12 to 15 minutes away from entry start as well. So we're already at an altitude of 154 kilometers, 154. Heavy clouds, 159 kilometers up. That's what I'm saying, Cobra. Like, what is that we're looking at? If it's all just venting, it's weird. The way it's moving like that, because it could just be a vent. Like, this could be, is this top or bottom? This could be a bottom camera and we're seeing the gases come over the top of the camera. Regardless, it's kind of weird to see this, I'm not gonna lie. Fast forward, please. Yeah, I know, right? I wish I could, but we are live. This is live. It's even reflecting on the hull. I know, I see that. So this could just be a lower body flap camera. And so, no, that's actually the payload bay door right there. So this is on the top. So I guess it's venting from the top then? Huh. Looks like it's accelerating, yeah. Because don't forget, there are vents on the top of Starship. So it could just be that. It's just weird in the lighting for sure. But let's see, all right, I don't want to play that music just in case. I think it's all VOD safe music, but I just want to make sure. So we'll tune in here. We should be about 2 minutes away from the engine ignition, so they should be coming back on the broadcast here momentarily as well. The front fell off. Yeah, I hope not. Yep, it's all reflected on the skin. Yep, and we are on the top facing down, so the engines are down here. You can tell because that's where the payload bay door is, so the payload bay door is on the top. Yeah, it's definitely just from venting. But it's really interesting how that's playing into like the camera orientation. There you can see the functional catch tower pin. Now we're looking at the aft body flap.
I've essentially lost attitude control on the ship at this point.
We have lost attitude control.
Suborbital, so it's still headed to the exact same trajectory
no, chat.
as before.
Tumbling indeed.
We were not able to get that payload door open and
there
deploy those nose cones.
Confirmed. It is tumbling uncontrollably.
This is also what led to that loss of attitude control. So at this point, we are kind of in a spin, and we are also going to be skipping that Raptor relight. If you've followed through the history of Starship, something similar happened, different cause but same symptom. Back on
if it was tumbling, I think there would be some video dropouts. Well, they have Starlink though, and Starlink is technically above them, and they have 4 antennas on board. So
that Raptor engine while we're in space, we are going to still proceed with entry. But as we are not able to control the attitude of the ship,
where
as we get into entry,
this venting is happening, because it does look like a lot.
Time, which does not bode well for the ship's heat shield, as we're not going to be essentially aligned the way that we want to do for reentry. So it is definitely coming down. It is definitely heading to the Indian Ocean, but our chances of making it all the way down are pretty slim.
Oh, come on. Where's your brave face?
Get as much data as we can.
It's going to make it, chat. It'll be fine. They don't need attitude control. It'll be fine.
Time, and we'll continue to stick with ship as it continues.
So maybe that rotation back then and all the venting wasn't so great. Yeah, maybe.
Until we start getting.
But they do on like Falcon 9 and stuff. Do rotate the vehicle when they go to separate, so that way they have momentum, angular momentum during separation. But
as long as we maintain that comm link, get some plasma on the way in, and start to bring the Starship back through the Earth's atmosphere. So that coming up in about 10 minutes or so. So we'll check.
Well, chat, buckle up because we're about to see some serious stuff. It'll land all right, yeah. It may be in a lot of pieces during burnup. What if it stabilizes on reentry through excitement guaranteed? Maybe. All right, so they're back to the music. All right, so that's interesting, chat. We learned that there has been an anomaly. There's an anomaly? Complete loss of attitude control? That's not great. What do they use for their attitude control? Is it just header pressure? Do they actually have separate tanks for attitude control, or is it all just boil off? I'm not sure. I'm not sure what or is it cold gas? I can't remember. It's not cold gas, right? I'm just trying to think, like, why would they lose attitude control? And why is it all this venting? Yeah, this is definitely venting coming off the top of the vehicle. The reason why it looks like it's being, like, enveloped in this is because we're on a camera near the top. The vents are quite literally like right above the camera here, as far as I remember. So the vent is literally venting out and coming over the camera, and that's why it looks the way it is. It looks like the entire vehicle is enveloped. But yeah, that's a lot. Oh wow, a lot of venting. It's Flight 3 all over again. Yeah. They do just use tank ullage for RCS. Interesting. Yeah, don't know, chat. Definitely a lot of funnies going on in this vehicle. Maybe not venting? Well, if it's not venting, then what is it? Unless you think, are you saying like it's an RCS valve like stuck open or something? All right, we're at 117 kilometers. We should actually start seeing reentry heating here pretty soon. That's part of the reason why the lighting effects are so spectacular, as we are starting to see the gases start interacting with the upper atmosphere. What's near the top? One of the header tanks. Yeah, one of the header tanks. Huh. Well, Chad, it's not looking great. Let me tell you what. Version 2 is officially cursed. Yeah. Not great. It's definitely a leak. Yeah, it's definitely a leak. I don't know where the leak is occurring though. From that attitude rotation that we saw earlier, and if it's leaking, it's spinning faster and faster. Maybe upwards of like 20 degrees per second, but if it is even higher than that, it's amazing that we do still have camera feed. Even with there's the re-entry heating happening, chat. That's the re-entry heating. It's the gases impinging upon the atmosphere and starting to do those really awesome lighting effects. Maybe from that engine hotspot, but this is, I believe, from the top. I mean, at least, maybe it's not from the top. Maybe it is originating from the bottom, but I don't know. But it is getting toasty very fast, chat. I wish they would give us the telemetry so we can kind of see how it's rotating. Because I can't even see Earth. Like, I don't know where Earth is in this orientation. All right, so that's the engine bay. It's hard to tell, but it doesn't exactly look like there's a bunch of venting happening from the engine bay. So is the venting happening from the top then? Uh-oh. Okay. Stand by. Oh, okay, we're fine. We're still alive, chat. We're still alive. Oh no. Not looking good. It's definitely exciting though. Excitement guaranteed, chat. Good news, everyone. Not tumbling anymore. Bad news. It exploded. It's about to look a lot like, that's some more of the heat shields that they have on the inside of the engine bay. For a second, I thought that was like tiles or something. It actually doesn't look like it's tumbling anymore, right? Because it looks like from this engine bay view, the plasma is consistent in the direction it's coming from, right? It's been coming from this direction for a while. So it looks like it's stabilized, but sideways, question mark? We'll see how long it lasts, chat. All right, chat, place your bets, place your bets. The over-under is 60 kilometers. Over under 60 kilometers, chat. Are we gonna blow up before 60?
Bit off nominal, that we have enough airspace cleared out for situations just like this.
Yeah, re-entry is still just that really critical phase that we need to try and gather as much data, as much information as possible. Is a fully reusable heat shield.
There you go. We got one under, chat. Who's gonna take on bubbles?
Of space flight, and that's something that Starship still has to crack. And so we had a whole range of experiments on this one at this point, and we just started to lose some of our cameras. So it's very possible that we'll start to lose contact with
under
Starship,
60 kilometers. All right,
a lot sooner than we would.
Warlock says at 45 minutes, so around 80 kilometers. Oh, well,
so
we already lost.
Expecting it to break up. Essentially,
oh no, never mind. Okay, we got it back. For a second, I was like, telemetry was lost.
Not able to do a lot of our on-orbit objectives today, but just the fact that it
didn't blow up. It's going to blow up, but it didn't blow up yet.
Big moment.
The first stage blew up. Yes.
Another thing to note is that Super Heavy did fly for its second flight today. It first flew on flight 7. All right,
we're coming up on Warlock's time.
It made it all the way to
it's at 80. We still have telemetry.
Of all the engines and stage separation, getting ship into its suborbital trajectory today. It did ignite its 13 engines, but it did demise at that point. We did plan to fly it back down to Earth at a higher angle of attack, and we do expect it to stress the vehicle a lot more than what we've seen previously.
All right, we're past the 45-minute mark. Warlock's out.
We did lose the booster before we got to the actual landing.
Yeah. So we're gonna continue to hang out and see if we get any updates on ship. It does look like we might be getting some video back soon. There we go.
Oh, it's rotating.
So this is a view essentially.
Oh, those are tiles.
Top part
those are tiles
Starship,
coming off.
You're looking up at the payload bay, and towards the nose cone. So
views
are going to be
look,
a little bit scarce,
you can see the ribbing underneath the flap.
In essentially,
you see how the heat is starting to crumple.
So Starlink, when it's able to connect, able to feed this down. We are at the phase where we would expect entry to start within
it's starting to do this,
chat. So we are
doing this now,
uncontrolled. But again, we're entering into an airspace.
Oh, look at that
and
plasma!
A space that is cleared and monitored in advance of launch.
This is looking up.
This phase.
And with the views that we are able to see, you are seeing
a lot of that I should say up from perspective of Starship. Starship is still coming in like this, right?
To see about 1400 degrees Celsius in there. You can see the
the
flap.
Well, there goes that flap.
That temperature there, a little bit melting away.
Oh no!
But
the tiles are gone on that flap. The tiles are gone, chat. The tiles aren't there.
Of the vehicle,
tiles couldn't help that one.
We are no longer controlling the attitude of the vehicle. So this is now at this point in the test flight. It is expected to see it begin to.
For sure, Naps. Yeah, the video of the breakout up, I'm sure is going to be valuable.
We'll stick with it for as long as we're kind of getting.
All right, we lost telemetry for the moment
from the ship as it starts to make this re-entry.
But we're below 60, chat, and still.
But
the last update was below 60.
So it's re-entering actively right now. And again, we did do what's called passivation. So you essentially vent all of your excess propellant overboard before you hit the atmosphere.
We're not getting any telemetry updates.
We can take on the ship while you still have contact.
That may have been it.
So that was done. It's now coming down in the predetermined hazard area that was cleared ahead of flight. Not controlled, so we're not going to get all of that reentry data.
At 59.3, chat. I said over under 60. 59.3 was the last telemetry update we got.
Of ship. It has different flaps, improved heat shield, a whole lot of things that we're really trying to really put through the ringer. As there's a whole lot we still need to learn
the camera footage.
Get to kind of the next step that we're hoping for, which is going to be that ship going orbital and eventually coming back here for a catch. So getting through one of these fully is going to be really important. It's not going to be today.
Clearly.
But we are just going to stick with the ship, see what else we can learn.
The plasma was gorgeous.
It makes its way through the atmosphere.
For sure. Never disappoint seeing Starship entry.
Test. So we'll stick with it.
Well, the fact that we haven't gotten any other camera footage makes me think that we're not going to get any more camera footage. It is through the peak heating portion of the flight at this point, below 60 kilometers. We were already seeing parts of the vehicle melting off. We were seeing heat shield tiles detach. Pretty sure it's gone. I'd be shocked, I tell you, if we get another footage, another frame from a camera with it still in mostly one piece. Take a gander and say it's a goner. Yeah, I'm kind of with you there. Kind of thinking. But we will sit and we will wait. At least the Bahamas are happy today. That's true. Yeah, that is true. Think of the light show that you should be seeing out in the middle of what is that? The Indian Ocean down that way. Yeah, it should be quite the light show.
If you're just now joining us,
that's going to conclude our broadcast.
On-time liftoff from Starbase, Texas.
Is it not coming on then? Yeah, it's
Central
definitely not. Nope, it is not.
The Flight 9 vehicle. We did have some incredibly stressing objectives today. The Super Heavy booster flew for its second flight. It first flew on Flight 9.
No landing burn. Nope. I would think not.
They passed all the way up to stage separation.
Went through passivization.
Doing its first second flight ever, which is pretty incredible.
Basically meaning that they vented down the tanks and stuff. It's basically a vehicle safe.
Back down at a higher angle of attack.
It's not going to be turning on.
We did have it demise on the way back down.
Yeah, we were able to get all the way to that landing burn though, so we made it through that higher angle of attack. So. A lot of great.
For a second, I thought they were talking about Starship. I was like, "You made it through landing burn?
Yeah, we did
no,
the
you
directional
didn't."
flip, and it worked.
Yep.
It was actually a great view that we saw.
It did flip in the right view. I mean, it looked good on the flip, so that's cool.
The beginning of its flight, making it all the way to Seco and coasting for quite a while.
You bet the Pez dispenser doors open? Probably.
The expected time that we would open the payload door. Unfortunately, the door did not open as we expected it to, so we did not deploy the 8 Starlink satellites.
Yeah, we ran into a couple of issues once ship got there, but I can tell you it was a pretty crazy moment for a lot of the people that were standing here for ship to make it there. It's been a couple of flights, but it was really exciting
to say the least.
Ran into some issues on orbit. We weren't able to deploy the Starlinks. We eventually lost attitude control, dealing with some propellant links inside of the ship. And we did lose attitude control. And just to confirm, we did lose contact with the ship officially a couple of minutes ago. So that brings an end to the 9th flight test. So still a lot of work to do, but really big moment. Chris, how's everybody doing over there?
Hey, they made it further than last time, chat.
What's the vibes, man?
Yeah,
that's success.
It's a test program, and that's what we're here to do. We're here to learn, and that was definitely.
I want to see if we can't. Well, let's see if let's actually have them wrap it up.
Through its objectives today, but with all of that data that came down through the Starlink system, we're definitely going to learn, and we're definitely going to fix that and push forward. Also, great to see
progress, not perfection.
Here in mission control,
step
talking
by
with the flight
step,
control
ferociously
teams in Starbase. We talked about how it's great having that expert knowledge on console.
Yeah, PEZ not working needs to be figured out because this is like the second time their PEZ dispenser hasn't worked.
Today, when we decided to passivate the vehicle, so we will be here looking forward to Flight 10 and some success on future flights.
All right. Well,
so got work to do, as
obviously,
they said.
Congratulations to everybody that poured so much time, effort into getting this ship, this rocket off the pad. The last 2 months have been an absolute gauntlet for a lot of people, and we're continuing to learn
Falcon 9
more
have
about
this
the
many
ship,
problems
about
during
this
development
rocket.
and testing?
We are trying to do something that is impossible.
But also Falcon 9 was a much more slow, methodical development period, right? They went from first Falcon 9 in 2011 to first landing in 2016, 6 years. All of those being operational missions as well. Starship hasn't even had a first operational mission, and they're basically trying to do the whole thing all at once, right? So it's not really the same development track. And then also don't forget that the Falcon 1, which started SpaceX back in 2001, had 3 failures before their first successful mission. So, failure is a key point. Nothing this size in this way has been built. It's nothing but growing pains, right?
Now, this is not the end. We're going to have a whole bunch of cool liftoff stuff, so be sure to follow us on X at SpaceX for more, and we will see you back here for Flight 10.
All right. Well, thanks for tuning in. Very good. I want to go back. Ooh, that's the shot I wanted right there, chat. So what are we looking at here? Because that is clearly the flap, but is that actually the flap that we're seeing here? Yeah, I think it is, right? Because there's the back portion of the flap here, and it should basically extend all the way this way. I'm just trying to see, is that the flap we're seeing, or is that part of the engine bay section that's being peeled back? I think it's part of the flap, though. You can see some of the ribbing. Huh. Yeah, it's not looking great. Yeah, not looking great. And for that to be the aft flap that's doing that, oof, chat. Ooh, but that is very nice. That is very nice. Another failure, sad to see. Yeah, secret, or yeah, crit. Definitely was hoping to see them go all the way through landing, since they've already been there at landing, right, with Starship V1. But at least they have gotten further for Starship V2. So it's made it into orbit. That's interesting that they were having propellant leak issues, which made them lose their RCS control and their overall attitude control. We'll have to see about that. 100% hot staging causing damage. I don't know, because Starship V1 did it. Starship V1 hot staged multiple times without any problem and made it all the way through entry, right? So can you 100% definitively say that? I mean, I think it's more likely than not a multivariate problem, right? It could be hot staging with the fact that you've extended your overall V2 Starship structure, right? Extending that out causes different operating modes and structural modes and things like that than V1 Starship. They're changing a lot. V2 Starship has a lot of changes that they're all trying to just make work all in one go, right? So yeah, definitely we'll have to see. We'll have to see what this failure report comes out to be, right? No issues during testing? Yeah, but testing, right, there's only so much you can do testing on the ground versus actual operative testing. Yeah, and like I said, I have no data to go off of saying that it's not hot staging. It certainly could be. But most likely it is a multivariate issue. Could be hot staging with the fact that they've extended the vehicle structure, which creates different structural modes, and then they also have different downcomer configurations to feed the propellant engines or to feed propellant to the engines. Like I said, a lot of changes that they're pushing right now. Harmonics on the longer body may prove an issue. Yeah, I mean, that's what we saw on the Flight 7 failure, right? Was the harmonic structure issue. Basically bringing the downcomers and the propellant feed lines, separating it from the Raptor engine, causing leaks and then a fire and then an explosion. It's a big issue, chat. Or I should say it's a big, complex vehicle that has issues that they have to fix. Oh, but that is a great shot seeing the plasma. So again, I'm pretty sure that this camera angle is on like the top, or it could be on one of the flaps and the flaps are folded up or something. Because with the way that, there, you can actually see it perfectly. Look at that. So that whole bright spot right there is the plasma on the aft edge, and this is what we're seeing fall apart later. Look at that. Yeah, not great. And then it like cuts and it comes back and that part of the flap is gone. Oh yeah, you can see it start to eat through the flap. Interdasting. Very interdasting. But there you can see the plasma wake come back together on the side. And look, you can see all those bright spots happening right there. Like that one right there, that streak, those are tiles coming off from the loads and whatnot. What's up, Hellfish? How are you doing? But there you can see the melting of the flap starting to happen. It cuts out, comes back. You still see it starting to just eat away. Like I said, all those bright spots that you see are tiles coming off or breaking off. Let's see. That's the plasma wake. All of that right there are tiles coming off. Yep. Yep. Yeah. Oh, there you go. You can see part of the vehicle basically unraveling. Or is that actually the other side of the body flap? That actually might be the body flap, the way the wake is coming off. And then you come back to and you see this. Getting some burn through. Ooh. Getting some burn through on that body flap. Oof. Cool views? Yeah, 100%. My question is, what about the tank construction is so different that it's now causing problems? Or is it the size combined with the same construction? Most likely the size combined with the same construction, Hellfish, right? Because you can imagine if you're basically creating, for lack of a better analogy, I mean, I think the analogy still holds here. You're basically creating a cantilever beam, right? You have a big, long steel body with different, of course, internal components for rigidity. But as you increase the size, you have different modes that it can flex. And so if it's shorter, those modes are different, right? It can't flex as much. You extend that out, it can flex a lot more. It's, something like that can certainly cause stress and strain on the vehicle at different joining places where they have different barrel sections joined together. Yeah, just don't know for sure. Obviously, I'm not an expert on the Starship system. But yeah, definitely loads on expanding the vehicle could certainly be a leading cause here. We'll see, chat. But anyways, that is going to have to do it for the live coverage, I do believe. So kind of a little bit of a recap on what we saw today. Starship very much had a little bit of a troubling. It could have gone better. It could have gone better, Chad, I think is the better way to say it. Obviously, Booster 14-2 ended in demise, not getting to its landing burn. That kind of sucks, not having the payload bay door open on Starship V2 once in orbit to deploy the dummy satellites. That's a bummer. Of course, then having propellant leak issues, which then leads to a reaction control system issue, which then leads to an attitude control system issue. Complete loss of attitude control in Starship is a big problem. And then of course, well, that was really the end of the problem. I mean, it's not going to survive entry if it doesn't have attitude control, so that's not even part of it. But yeah, having Pez dispenser door not working and having loss of attitude control is concerning. So yeah, was really hoping to at least see it go through entry under control, even if it didn't survive entry. because that's a big one, chat. They've taken so many tiles off of this vehicle and whatnot to test and stress test the actual tile system and the design for V2 Starship that we really need to test it in entry during like an actual operative mode, like actual stable re-entry, to actually see how it performs. That's going to be a big one, because if it fails on the next flight going through re-entry, well then that's something that ideally could have been assessed during this entry, but we didn't get there. Anyways, I hope you guys enjoyed the stream coverage. Like I said, I'm kind of just back for today for Starship. I am looking to get back into streaming here in the upcoming weeks. Got some personal things I'm still working through, but overall, I hope you guys enjoyed the stream. But that is going to do it for me. On the Twitch side, I'm going to send you over to EJ SA. If he is still streaming, I actually don't know. Is EJ still streaming? Raid EJ SA. Is he still streaming? He is, I think, still streaming. Yeah. So anyways, go say hi to EJ for the rest of his stream. I think he actually is probably going to be ending soon. But much love for y'all hanging out on YouTube. If y'all are also interested, EJ SA is also streaming on YouTube at EJ_SA. So with that, chat, have a wonderful night. I hope you guys enjoyed the launch coverage. It was certainly exciting. A little bit of a bummer, a little bit of a downfall, a little bit of a, what would you call it? A deflating launch. I was really hoping for a solid launch all the way through to get back to Starship V1 perspective, but you know, such is life, chat. Such is life. But anyways, chat, that's going to do it for me. Much love to you all. I'm out of here. Go say hi to EJ, and we'll catch you on the flip side.